Bismillahirrahmanirrahim. Data structure lecture number 4 Kimanga tree terminologies value Biamanga value chair binary tree memory kisanga represent ki. Now, there are two ways to represent binary tree in memory. The first one is the link representation of binary tree, which we discussed in the previous lecture. The second one is called a single array, called is sequential representation of a tree. Now we are going to discuss the sequential representation of a binary tree. This is the linked representation of a binary tree for which we required three linear arrays, the called three linear pair arrays. Info left, info contain the data of the node, the left contain the address of a left child, and the right contain address of the right child. This one is the node which contain three. There are three arrays. This is the info which contain data. If you see that the node root 5 contain location 5 contain a, the left node contain address of the left child, and the right node contain address of the right child. This is the data. A left node will be contain 11 left child address, right will contain 2 right child address, and so on. This we discussed in the previous chapter lecture. Now we are going to discuss the sequential representation of a binary tree. Suppose T is a binary tree and that is nearly complete or complete binary tree. Now, complete binary tree are those tree which has two childs at every at the last level. We have two charts. Then the efficient way of maintaining tree in memory is called sequential representation of tree. Then we can store the data in a memory like a sequential representation of a tree. For this we have a tree. Tree is the name of the array in which we are going to store the data of the tree, and the tree 1, the tree first position will contain the root node. The tree first position contain the root node. Then the tree k means the left child is stored in tree 2k. 2k mean k is the location of the node in which it is stored, multiplied by 2 will contain the left child, and the right child is stored in k multiplied by 2 mean the location in which the root node is stored, multiplied by 2, and plus 1 will contain the right child. If tree of 1 is equal to null, if the first node is null, it indicates that the tree is empty. Now we are going to see this in the diagram. This is the root node. The root node is stored at location 1. Means the tree of 1 is equal to D. Tree of location 1 is equal to D, which contain the contents of the tree. Now the left child is going to be stored on location of a root node is 1. So 1 multiplied by 2 will count 1 multiplied by 2 is equal to 2, mean it an array the 2 position will contain E. Now the right child is going to be stored on location of a node. A node is 1. 1 multiplied by 2 plus 1. So 2 plus 1 is equal to 3. The 3 location will contain T. Now we are going to calculate values of this node, whether it is going to store it at which location. So the E is now the node or parent node or the root node for the rest of the child. So E is stored at location 2. So 2 multiplied by 2 will store the left child. 2 multiplied by 2 is equal to 4. At location 4 will be Y, and right child is going to be stored on 2 multiplied by 2 plus 1. So the value will be multiplied, the location will be multiplied by 2, so that position will contain the left child, and multiplied by 2 plus 1 will contain the location of the right child. So there is no right child, it will be empty. Now we are going to calculate this location. This location is location 4. The left child will be stored on 2 multiplied by 2, 4. 4 multiplied by 2, 8 location will contain the left child, and 4 multiplied by 2 plus 1, 8 plus 1, 9. 9 location will contain H. We are going to calculate the right child. The right child is T, which is stored at location 3. 3 multiplied by 2, 3 2s are 6, will contain K. Now this is 6, will contain K. And 3 multiplied by 2 plus 1, 7. 7 will contain S. 7 location will contain S. Now we are going to calculate the location of K. K is location 6. 6 multiplied by 2, 12. 12 will contain B. And 6 multiplied by 2 plus 1, 13. 13 will contain 13 will contain the right child. There is no right child, so it is empty. Now we are going to calculate location of S. S is at location 7. So 7 multiplied by 2 is equal to 14, will contain the left child. So there is no left child, so it will be empty. And 14, 7 multiplied by 2 plus 1, 14 plus 1, 15 will contain the right child. So it will be stored in memory like this. Now you are going to practice it manually. So in this lecture we discussed the sequential representation of a binary tree. Now we are going to discuss traversing of a binary tree. We are going to traverse a binary tree. Traversing means accessing each element exactly once is called traversing a binary tree. 3 standard ways are used to traverse a binary tree with root R. These 3 algorithms are called pre-order, in-order, and post-order traversing of a tree. Pre-order is called the free order NLR, node, left, and right. It will process the root node. Mean node is the node. Node means the at first location it will be root node. Then every node will be processed first, then the left subtree, and then the right subtree. In a pre-order, node, left, right. This is our algorithm. And the second one is the n order. The n order will contain the subtree, will traverse the subtree, travel the left subtree first, then process the node, and then the right node, then the right subtree. And the last one is the post order. The post order left tree will be processed first, then the right, and at the end there will be the root node. So all the 3 algorithms have the same structure, mean node, left, and right. So the free order will contain node in the first position, the in order will contain node in the middle, and the post order contain node at the last. So the first one is the process the root node, then traverse the left subtree, then traverse the right subtree. We are going to apply it is on this tree. So the first one is the, now you are going to remember this node, left, and right. We are going to process the node, then process the left subtree, and then process the right subtree. So in this tree you are going to see that 40, 25, 78, 10, and 32. This is a binary tree. We are going to process this at location. At step number 1, print the value of 40. We are going to print these values, mean it is called traversing. So we are going to print 40. Why? Because we need to process the node. The node is the 40. So we process the node, 40 is printed. Now the second step is, if process the node, go to the left. left is this one, visit the left subtree. So the second step is to visit the left subtree. So the left subtree is 25. 25, it is itself a node. So the 25 is itself a node, so print the value. The third step is to print the value of 25, so 25 is printed. Now the fourth step will be to visit the left subtree. The left subtree is 10. 10 is itself a node, so the fifth step is to print the value of 10. 10 is printed. Now left subtree is null, also right subtree is null. Process the left. The next will be to visit the left subtree, so the left subtree is null. Then node is processed the left subtree and then the right subtree. Right subtree is also null, so we going back to the 25. 25 node is processed. Now we visit the left subtree. Now it's time to visit the right subtree, so it 7 step visit the right subtree, and 32 is the right subtree node. So now if we are in here, so print the value of 32. 32 is printed. After 10, 32 is printed, so we print the value of the node, then process the left subtree which is null, process the right subtree which is also null. So we are going back to the root node. The root node is processed, left subtree is overall processed. Now we are going to the right node. It is the 10 steps. The 11th step is to visit the right subtree. The right subtree we are reach to 78, so 78 is itself a node, so we print the node. 78 is printed. Now we are going to visit the left subtree. The left subtree is null. Now we are going to visit the right subtree. The right subtree is null. So this is the required traversing of the pre-order traversal. Pre-order node will be processed first, then the left, then the right. So this is the traversing algorithm. Now you are going to see the next one is the in order and the post order. If there is any question, then ask me on the group.